let's do this next set of information in the about the normal model, finding other things other than the percents, other than the area, okay? So what we did yesterday was we were given information and then we just had to use DESMOS to find that proportion or that probability or that percent. So those were all shaded areas to find. And so what we ended up using in DESMOS, as you can see right here, we had used this little guy right here to find the area. All right, but now we might be doing something a little bit different, where we're going to be using a bound to actually find a location that has a certain area associated with it. So let's take a look at this first example. Here we go. So find the z-score if you have the area or the probability. We're going to use those bounds. So for example, the first one here says, hey, find the z-score for the lowest 10% of data. So that means I want 10% to the left, and what it's asking for is, what is this location right there? What is that z-score? So of course, since it's a z-score, then we're using the normal model, the standard normal model. So we're using this distribution, the normal distribution with 0 mean and 1 standard deviation. And so then you can see what we put in here. So we have left and we have bound. And what happens is when you do the bound button, it allows you to define this area right here. So I typed in 10% because I wanted 10% to the left. And then it will give you this value in here. It says, okay, then that means I have this bound of negative 1.28, which makes sense because it's a negative z-score and it's, of course, below the mean. Okay, so having that negative z-score below the mean. Okay, so I want you to try one of those. So the next one says the highest 5%. So number 2 says try this with the highest 5% of data. Okay, so we're going to go to DESMOS, and we're still finding z-score. So since we're still finding z-score, then we're doing the normal model that's 0 and 1. Okay, so we want to do that, and I cannot get anything to move on these. I think my little Active Inspire file has frozen up on me. It has not been happy lately. So it was freezing up on me earlier. Okay, well then let's go here to take a look at this DESMOS. Okay, so here we go, DESMOS. I'm going to put in that normal dist with 0, 1. I want to zoom fit so I can see what that looks like. Okay, so there we go. So we've got that. That is still not allowing me to do anything. It's still frozen up. Okay, so what did it say? I wanted to do the z-score with, so I want to find a bound, an area, a bound with 5%, the highest 5%. So that means I want to go to the right and look here. Make sure you put that 0 in correctly. It's 0.05, not 0.5, 0.05, okay? So then that's telling me that this line right here is that 1.645. So you can see, I just marked this here, so you can see that 1.645. There's that whole fraction right there, 1.6449, okay? Now, I will tell you that it's been my experience that College Board uses z-scores to 2 decimal places. It does those percentages or those areas to 4 so that when you move the decimal twice, you have 2 places. And we do z-scores to 2 places. All right, so let's see if my little thing works here. Do you want to save it before flattening, yes. I tried to do that already. So let's see if I can't open that back up. I'll try this one more time. See if I can get that to work. All right, try the next one while you're waiting on me to get there. What is the next one? Does it have an area in the middle? Maybe. Let's see. Yep, it says the middle 50%. So now that we're talking about that middle 50%, let's go and try that. Okay, so how is that going to work? We're going to go here to our Desmos, and we're going to do inner 50%. So 0.5. Well, so then, of course, if you have the inner value, you have a bound on the left and a bound on the right, and they're symmetrical. So look at what those values are. They're going to be the same thing, but one's on the left and one's on the right. By the way, if I come down here and I type x equals that, FYI, then it'll show up in my Desmos as a line. So I can see those two different lines easier, okay? All right, so that's how you find the z-score bounds with a certain criteria of a area. All right, let's see what's next. Okay, I already had you try that. The lowest 15%, so I'll let you do that. If you want to try that yourself, you can come on down. I think you're probably fine with these. When we used the TI calculator, it was more difficult. So we didn't just have it, we had a little bit more involved. And but now with the Desmos, it's so much easier. So I think you're fine. We'll go to the left, 0.15 to the left, 0.08 to the right, and then 0.2 in the middle. All right, next, now let's start putting in some context. So a reminder of the work that we want to show. We want to define our x value. What is our context that we have about? Okay, then we want to write that normal model notation. So here, let's go with this. We'll just work it as we go. So we have the Beanstalk Club of Texas for women who are very tall, women and men who are very tall. If a woman's height has an average of 63.6 inches and a standard deviation of 2.5, find the following cutoff heights. So that's finding a value, a height. And x is what you're going to be finding, okay? So what we're going to do is define x. X is the height of a woman in the Parker County Beanstalk Club. The Parker County chapter wants to take women who are taller than 1.75 standard deviations above the mean. So first thing, defined x. Second thing, wrote out the normal model notation of what I'm dealing with. A normal model with a mean of 63.6 and a standard deviation of 2.5. And then number three, either you're writing that probability notation, that P of whatever it is you're finding. If you're finding an area, if you're finding a probability, a proportion, or a percent, you're finding, put P of something. But here, we weren't finding a proportion or a probability or a percent. We're finding something else. So I'm going to define what I'm finding. I am finding the cutoff value, the x, the context height, when the z-score is 1.75. All right, so now show a labeled picture. So if it's a probability notation, you're going to have a labeled picture with a shaded area. But if it's something else, you might have a z-score formula instead. And that's what we're going to have here. So take a look. We got z is 1.75. So I'm going to fill in, here's my little z-score formula. Let me scoot on down here and show you what I got going on. Let me cover up the rest of these things here. So let's see here. All right, let me cover up this so I've got some room to work. And so here I go. So here is my formula that I'm dealing with, and so I want to fill in the things that I have from that. My z-score is 1.75. Okay, so there's my z-score of 1.75. My x is what I'm going to find. And then there's the mean and there's the standard deviation. From here on out, now it is just Algebra 1. Okay, so if your algebra skills are not solid, then this is now where you're going to start struggling. Okay, so let's take a look. I need to solve for this x. So what we're going to do, we're going to get this 2.5 off the bottom. So we're going to multiply both sides by the 2.5. Okay, we're going to multiply both sides by the 2.5. All right, when we do that, we have x minus 63.6 on the right, because those cancel, equals whatever that 1.75 times 2.5 is. So I'm getting my phone out here real quick. So that is my 1.75 times 2.5, 4.375. So I've got 4.375. Okay, now I'm solving for x. So what am I doing? I'm going to add this 63.6 over to the other side. So I'm adding that 63.6, and then that's how we're going to get the x value. So I have that typed out here. Let's take a look. And there it is. 67.975. So the woman will have to be 67.98 inches tall. All right. How about this one? If Tarrant County wants to make it, so Tarrant County, so it's a different county, and they have different qualifications for the Beanstalk Club. So here we go. They want to make it so that only the top 8% of women can be in the Beanstalk Club. So there we have something different. On the other problem, we were given a z-score. Here, we're not given a z-score. We are told top 8%. So they are telling me a percent instead of a z-score. So here's a picture. I want to find this cutoff value, this x, with this top 8%. So that's what's happening. So this actually can be done with DESMOS. Yay! So let me show you that. All right, so come on over here to DESMOS, and let's get our information in. Okay, so remember we got normal dist. Was it 63.6 is the mean, 2.5 is the standard deviation, okay? And let's see. I'm finding that x value. I'm finding the cutoff value. I'm finding the bound. So here I go bound. And what was the criteria? 8% to the right. So then I come on back here to my DESMOS, and I have area to the right. And I put in here, not 0.8, 0.08. And I think you can just do 0.08. But now, remember, I don't have it showing up here. How am I going to fix that so you can see what's going on? Don't forget to come over here and zoom fit. There it is. Ta-da! So here is the top 8%. And here is the value. I'm going to click this and bring it on down. And I'm going to show you that by typing x equals, because that's my context value, and there it is. There is that bound. That is how tall you have to be, a woman has to be in the Tarrant County Beanstalk Club, 67.11 inches. So there we go. So it actually came straight out from DESMOS. Nice. So that was a good one. It was when we had this z-score given to us. We had to do the z-score formula. Okay? So here's another one. How about this? We have 88% below it. You have to be taller. Oh, you have to be in the 88th percentile. That's how it was described to us to be in the Dallas County chapter. Okay? So 88th percentile means I want 88% below it. So I'm going to come over here to DESMOS and do the same thing. But instead of the top 8%, I have left 88%. So I'm going to go 0.88 to the left. And so there it goes. And I can then come on down here and see that whole value, 66.53. If you want to see it on the screen, here it is. Okay, so notice what I did was I defined what I'm looking for. Normal model, find x with 88% below it. Quick sketch, and now answer it. So there's my work I am showing. X is 65.4 inches. Okay, so next, now we have a new problem. And I think that, so let's just let you practice that real quick. So let's kind of go through these. Let's see if you can't do these on your own. And then we'll go to the last page because I think there's just a lot of practice here, which you could pull out. You could pull out the answer key that I have here online and check yourself with those. So here we go. So we have a pizza parlor. They are required to have a certain amount of cheese. You don't want to have too much or too little, and so there are some requirements. So they know, on average, there should be 8 ounces of cheese on a large pizza with a standard deviation of ½ of an ounce. All right. So here we go. First one, an inspector picks out a large pizza at random in one of the franchises, in one of the pizza parlors they have, and they find that it is made with 6.9 ounces of cheese. Okay, so that's underweight, so they're kind of gypping the customers on that. If the pizza parlor is really putting 8 ounces of cheese on the large pizza, then what is the probability that that randomly chosen pizza has 6.9 ounces or less? Okay, so let's think about what it's talking to me about. So first, what is X? What are we looking at here? X is the amount of cheese on a large pizza in ounces. Okay, and then what define our normal model? Our normal model is centered at 8 ounces and it is a standard deviation of 0.5 ounces. All right, what are we looking for? So look, it says here, we are looking for the probability of getting a pizza. Or you could even say the proportion of pizzas that have 6.9 ounces or less, the percent of pizzas that have 6.9 ounces or less, the P, probability, proportion, percent. That means I'm going to be doing this, setting my criteria of probability, the P of X being less than or equal to 6.9. Now at this time, you don't have this little answer here. Okay, so this little answer right here at this moment is unknown. Okay, so then we have our picture. Okay, so remember we're talking about what work is showing. We just wrote out that probability notation to define what we're looking for. So show a labeled picture with the shaded area. So here is what we are wanting. This is our area. So all the ones like this, probabilities, areas, can come, we get those easily in DESMOS. So let's go to that. We have a new normal distribution. Normal dist of 8 and 0.5, a ½ an ounce. Okay? Cumulative probability, we are finding the area. And to the left, below 6.9 ounces. So below 6.9. Okay, where is it on this picture? It's not there because this is way up in the 60s. Come over here and zoom fit. There we go. There it is. So there's my picture. That's the picture I screenshot. And see, look at this area. Okay, so 0.0139. See, 4 decimals because when we have 4.4 decimals, that's basically saying 1.39%. See, when I do 4 decimals, that's 1.39%. See, that's decimals or percentage to 2 decimals. So you can say either one of those answers. But 1.39% of pizzas are going to be underweight accidentally. Okay, not very many of them, but it could happen. All right, so there we go. Next question, same idea, but it says, hey, what is going on? Because we have an issue where the amount of cheese on a pizza is 3 standard, what if the amount of cheese on the pizza is 3 standard deviations below the mean? Okay, so right there, it tells you something. 3 standard deviations below the mean. We really hounded into it yesterday. The number of standard deviations below the mean is the z-score. So when they say 3 standard deviations below the mean, they are saying z-score is -3. Okay, so they're in danger of losing their franchise if the inspectors find a pizza with that little cheese on it. All right. So what's the actual context amount of cheese that can be placed on the large pizza? So how many ounces is that at 3 standard deviations below the mean? Okay, so what are we looking for? We still have ounces of cheese on a large pizza with that same mean and standard deviation. We are wanting to find x when z is -3. Okay, so, you may choose to just go mean and then subtract away 3 standard deviations. That works if you show your math, So if I show, I'm just taking 8 and I'm going to subtract away 3 of these standard deviations. Okay, then there you go. That's another way that you can do this. So what is that? Is that 6.5? 6.5 ounces. Okay, there you go. That is a way to find the answer. Okay, another way, if you're kind of like, my brain doesn't work that way, here is what you could also do. Say negative z-score. Z equals x minus the mean over the standard deviation. X minus the mean over the standard deviation. And then go solve it. And x is 6.5 ounces. So brains work differently. As long as you show your thought process, you are fine and it is valid, okay? And you've defined all this information, then you are in good shape. All right, and let's do the next one here. What's the amount of cheese that is in the bottom 5% of pizzas can have on them? So we have the same context and normal model. We are finding x with the bottom 5%, okay? So let's think of what that means. Finding x, I have that bottom 5%. So I'm finding a bound. I think I can go do that in Desmos, so let's go look. Here we have our thing. I'm finding a bound. I'm finding that x value with the bottom 5%. So I'm going to go put 0.05 right here. And voila, there it is. So what is this saying? This is x, okay? So that's telling me the ounces of cheese you can have on this pizza, so that you are if you have that much or less, you are in the bottom 5%, okay? So round that, 7.18. 7.18 is what that should round to. Or less, you would be in that bottom 5%. Okay, and then the last one, does it give me, top 5%? So look at there, 5% above it. So there it is. You're just going to do 5% to the right. Now this next question is the last one I'm going to do before I go to the last page in our notes and do something a little different. What do you notice about the z-scores for the bottom 5% and the top 5%? So that's interesting. You may or may not have actually found the z-scores to solve this problem. So if I'm going to answer this question, then I need to find those z-scores. So I've now, because of part C, I've got x values and the mean and the standard deviation. So let's look at what I did here. X minus the mean over the standard deviation is that z-score. And the top one, x minus the mean over the standard deviation is that z-score. So what do you notice about those two z-scores? They are the same. One's negative because it's the lower 5%, and one of them's positive because it's the top 5%. So that's all that's happening. All right, we are not going to do the rest of all of these. This is another problem and with context, so you can practice that and you can go on and do that. Also, the top of the next page, same thing. It's just practicing, practicing, practicing. It is down here at number 14. This is the one that I'm interested in talking to you about because this one is now different than any other ones we've done, and it's something that could happen. So the dogs are barking again. They're barking. You know, we out at nighttime here, we get out, all the possums are coming out, or people are walking their dogs or whatever, and so the dogs are barking. Okay. So here we go. So we've got this situation. It doesn't look like we're doing much context. We're just doing the things. It says the mean is 1250, 35% of the data is below 1200. So that's interesting. That means 1200 is the x, okay? 1200 is the x. And then the question is, what is the standard deviation? All right. So that's rough right there. Okay, first of all, I know I've got a mean of 1,250. Oh, and see, I don't have my standard deviation. So what goes through my brain is I'm thinking, I'm kind of messed up because I don't know the standard deviation. So I cannot do this in DESMOS, okay? I got the mean, but I don't have the standard deviation, okay? So that's kind of like I can't do that. So now I'm gonna have to figure out my other stuff. Okay, so let's see what I got here. Because I have been told 35% of the data is below this certain location, I can find the z-score. This is the key. I can find the z-score and handle my 35% to find the z. So that's the first thing I'm going to do. So this is a two-step problem. First, find the z-score. And remember, z-scores are on the standard normal model. So the z-score needs to use a normal model with 0 and 1. So I'm going to get the z-score at the lower 35% to find that bound, that location on the standard normal model. So I actually am going to be using DESMOS some, but it's not going to be the end of my answer. So I go normal, I think I need to normal dist of 0, 1. So here's my standard normal model. I want left 35%. So bound at the left 35%. Okay. So here's what that tells me. Let me go find that. Okay, there we go. So that's the bottom 35%. The z-score is negative 0.39, 2 decimal places. So what I have found is that my z-score is negative 0.39, okay? And then I'll walk you through this other part real quick. So I found a z-score is negative 0.39. Okay, so that's the first major step, is get that z-score. Okay, z equals negative 0.39. Now that I have that, now I can find x. Okay, so now find the standard deviation. Okay, and because now I have x and the mean and the standard deviation and the z-score, x, mean, and the z-score. So I'm going to put all of those three things in the z-score formula like this. Look here what I have. Z equals, there's my x, okay, there's my x, and then here's my mean, okay, and then here, of course, is the z that I just got, okay, and then I'm going to solve for this standard deviation. All right, so let's process that for a second. That is tricky, okay? This is as tricky as it gets. This is as much as this is as tricky as this unit gets, period. All right? So again, we're told a percent, and we've got to turn it into context. Well, first I have to get a z-score. A percent can get me a z-score. The percent is not the z-score, but I can use that percent to get the z-score. That's really, really important, and I actually have a song about that. Percent is not the z, it's not the z. Use the percent to get the z. It's the standard model, standard normal model of the mean of 0 and standard deviation of 1. And I'm going to get the percent is not the z, but I'm going to use it to get the z. All right, so now let's come over here. Here's the other thing. Man, my students lack algebra skills. And so I'm going to do this with you once. I'm going to go do the algebra on this with you once. And then I'm not going to do it anymore. And you better, you're a senior. You've gone through all the maths. You better learn how to do this math. So here we go. What's bad about this? Just the gross part is that I have an unknown on the bottom of the fraction. So I need to get it off of the bottom. I'm going to multiply both sides by standard deviation to get it, the unknown, off the bottom. And then that comes over here. So what I have is negative 0.39 standard deviations equals 1200 minus 1250. Well, I can do that in my head. That's negative 50. Okay, so there we go. Negative 0.39 standard deviations equals negative 50. Okay, now from here, we're going to divide by negative 0.39. Divide by negative 0.39. So that tells me the standard deviation is whatever that comes out to be mathematically. Okay? So negative 50 divided by negative 0.39, that comes out to be, let's see, la-ti-da, okay, 128.21. That standard deviation is a distance. It should be positive. So the fact that I divided by negative 50 by negative 0.39 gave me a positive 128.21. Whatever the context is here, I don't know what it is. Okay, so you could go and try the next one. If you were like, whoa, I struggled with that, then come here and do this next one. It's the same. The mean is 0.64. I have 12% of data above this X value right here. So X is 0.70, okay? So that's the X value. So you go do that one and then find the standard deviation. So the first thing you had to do was go get a Z-score. So I'm gonna let you do that. Go get a Z-score. The Z-score ends up being this, 1.1, it should be 1.18. I probably did this when I did inverse norm in my calculator and it didn't round it. Anyway, I put 1.17. X minus the mean over the standard deviation. X minus the mean over the standard deviation. Yeah, I can't do that. I can't do Desmos even at that point. Now I have to do this Z-score formula. Okay, so I'm going to multiply to get that off. Divide by 1.17, so the standard deviation is 0.51. Okay, now let's take a look at the next one. It wants something different. It gives me the standard deviation, and it says 90% of the data is above 10. Well, once again, 10 is the X, okay? And it's asking for the mean this time. All right. So, percent is not the Z. It's not the Z. Use the percent to get the Z. So here we go. I'm going to go to my standard normal model. I have, what did it say? 90% of the data is above 10. So 90% to the right. Interesting. So 90% to the right. There we go. And so 90% to the right. Ah, interesting. Okay, see, look, if I have 90% to the right, then my Z-score is located here at negative 1.28. It's down here below the mean, so I got negative 1.28 is my Z-score. Okay, so there we go. My Z-score is negative 1.28, and I want to find the mean. So I'm going to come down here, and we're going to practice that. Here's another one where, once again, my students cannot do Algebra 1. So I always take a moment, and I do one problem where I'm going to show you the hardcore Algebra 1, and gosh darn it, you're seniors in high school, and you've been doing this for a long time, so I'm showing you one, and you better get it. So here we go. I'll show you one, and you can practice one on your own, but let's go. Okay, so here what do I not like about this? I don't like that I have something on the bottom of a fraction. That's the gross part, so I'm going to get rid of that. And it's dividing by 0.5, so I'm going to multiply by 0.5. Cross that out, so multiply by 0.5. All right, so negative 1.28 times 0.5, what is that? I don't know, what's half of 128? Is it 64? So this is negative 0.64 equals 10 minus the mean. Okay, here is the thing where my students mess up. So I'm going to, again, show this to you once. Here we have 10 minus the mean. I want to get the mean by itself, but it has minus the mean. I'm going to move the 10 over to the left. But what's in front of this is really like a plus 10. So to move this 10 over, I am subtracting 10. And I've got negative mean equals negative 10.64. Therefore, change the signs, and my mean is 10.64. Was it 10 or 0.10? I don't know. Let's go check. All righty. It looks like it was 10. So here we go. And then I subtracted that 10 over, and I get the negative mean is the negative 10.64, so the mean is 10.64. Okay, I'm going to let you practice one of those, and then that's it. That's all the algebra I'm going to do with you. So here we go. We have got 3% below 202, so that's your x value. 3% below 202. You ready? Percent is not the z. It's not the z. Use the percent to get the z. All right, so let's come on over to our Desmos. Percent is not the z. I got 3% is the left. So 3%, 0.03 to the left. There's a picture. And so there is the z-score. Percent is not the z, but the z-score is negative 1.88. So here I go. The z-score is negative 1.88. I'm going to move this. There we go. And now I set it up. Negative 1.88. X minus the mean over the standard deviation. Now I'm going to multiply by 220. Subtract 202 over. The mean is 615.5 if you did that algebra correctly. Okay, that's it. So in summary, today's lesson, finding the bounds, finding the z-score, finding something other than the probability. Because probability we did yesterday. That's easy. That's in Desmos. Okay? So you might have to get the z-score so that then you can do algebra with the z-score formula and do the rest. Okay? So that's part still there. The dogs are starting to go crazy, so that must mean I need to be done. Up. Okay, you ready? Here's Pumpkin. 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 Come here. Hi, baby. Okay, here we go. You made it through all the notes. Let's see Pumpkin. Pumpkin, come here. Okay, come here, you little baby. Ugh. She's not a little baby. Here she is. Okay, there's your treat for making it through to the notes. Here's my pumpkin. There you go. Mwah. Okay, done. All right, there you go. So go now, practice your assignment, and we'll check it later. All right, we're done.